T minus 0. Engines ignite. The ground shakes. And somewhere inside that rising column of fire, a human body is about to leave the only environment it was ever built for. For thousands of years, Mars was nothing more than a red point of light in our night sky. Today, it's a destination. Governments and private companies are pouring resources into the technology that could one day put permanent human settlements on its surface. But before we ask whether humans can live on Mars, we need to ask a harder question first. Can the human body survive leaving the planet it evolved on at all? Mars colonization, the biological price of leaving Earth, every part of you, right now, was shaped by conditions unique to this one planet, one steady gravity, pulling consistently in the same direction every second of every day, a protective magnetic field deflecting radiation before it ever reaches your skin, a thick atmosphere holding in warmth and breathable air, a stable day-night cycle your entire biology is built around, your bones, your muscles, your immune system, your heart. Every one of these systems developed, generation after generation, inside this exact set of conditions. Mars offers almost none of it. Leaving Earth doesn't just mean leaving a planet behind. It means leaving behind the very forces that built the human body in the first place. Mission Day 1. Departure. The challenge doesn't begin when the spacecraft lands. It begins the moment it leaves Earth's orbit. For 6 to 9 months, astronauts would live inside a small, sealed vessel, floating in microgravity, exposed to deep space radiation, and isolated from nearly everything familiar about human life. This journey alone would become one of the largest medical experiments ever conducted on a living human body. Mission Day 14. The body begins adapting. Without gravity pulling against them, muscles begin weakening almost immediately, since they no longer have to support any body weight at all. Bones begin losing mineral density gradually, quietly, increasing the risk of fractures that would have been unthinkable back on Earth. Body fluids shift upward toward the head, affecting vision and putting new, unfamiliar strain on the cardiovascular system. Researchers aboard the International Space Station study these exact changes today, using strict exercise routines to slow the damage down. Not stop it entirely, just slow it. Even our best current science can only manage this problem. It can't yet solve it.
Mission Day 60.
Mission Day 60. The invisible threat. Out here, far beyond Earth's protective magnetic shield, there's almost nothing standing between the human body and deep space cosmic radiation. These high-energy particles can damage DNA directly, raise long-term cancer risk, affect the nervous system, and may even contribute to cardiovascular disease over time. Scientists are actively researching radiation shielding technology because this remains one of the single greatest obstacles standing between humanity and any long-duration mission beyond Earth's protective bubble. It's not a problem you can outrun. It's a problem you have to shield against every single day of the journey. Mission Day 210. Landing touching down safely is only the beginning of an entirely new set of challenges. Mars offers a thin, barely there atmosphere. Gravity roughly a third of what your body evolved to expect. Freezing temperatures, massive planet-wide dust storms, and soil laced with chemical compounds called perchlorates, toxic enough that future settlers would need to handle Martian dust with extreme care. Most of daily life would happen inside sealed, pressurized habitats, entirely dependent on advanced life support systems just to keep air, water, and food flowing. everyday life on Mars wouldn't resemble everyday life on Earth in almost any meaningful way. Mission Year 1. The bigger question begins. Could humans actually adapt to Mars permanently? Not just survive a single mission, but genuinely live there generation after generation. Researchers are actively studying how lower gravity might affect long-term bone development, muscle growth, immune function, and overall human health across multiple lifetimes. But here's the truth. No human has ever lived on Mars permanently. No human has ever been born there. So the long-term biological consequences remain quite simply unknown. This isn't a gap in imagination. It's a genuine gap in scientific knowledge, one only time and future generations could ever fully answer. Mission Year 2. The mind faces its own challenge. The human mind evolved on Earth too, shaped by oceans, forests, rain, open skies, and fresh air blowing across open ground. Future Martian settlers might spend years, possibly entire lifetimes, without any of that. Isolation, confinement, communication, delays stretching many minutes each way when speaking to Earth. An overwhelming physical distance from everyone and everything familiar. Mission planners today consider mental health every bit as seriously as physical health, because a habitat can keep a body alive without necessarily keeping a mind well. Mission Year 5. Adapting through technology. Humanity has always responded to hostile environments the same way, through technology. Mars may demand the single greatest technological adaptation in our entire history. Scientists are working on advanced habitat designs, improved radiation shielding, new medical countermeasures, and life support systems robust enough to function reliably for years without failure. Whether all of this will genuinely be enough remains one of the biggest open questions in the entire field of space exploration. Mission Year 10. The bigger picture. Mars may very well become humanity's second home someday, but every single step away from Earth also means stepping further away from the exact environment that shaped human biology across millions of years of evolution. Perhaps the hardest part of colonizing Mars was never going to be building the cities, the domes, or the life support systems. Perhaps it was always going to be this: understanding whether the human body and the human mind can genuinely thrive somewhere else entirely. Remember that rising column of fire from the very beginning? The moment a human body first left the only environment it was ever built for, multiply that moment by years, by generations, by children who might grow up under a sky that was never blue, on a planet with gravity that was never quite enough. If future generations had to physically adapt to survive on an entirely different world, would humanity still be the same species, or would we, quite literally, become something new? If this made you think differently about what it actually takes to leave Earth, that's exactly the kind of question Secret Horizon exists to explore. Every episode, we take a real unfolding scientific frontier and follow it all the way out to its hardest, most honest questions. Subscribe so you're here when the next mission update arrives. And if there's a corner of space exploration you want us to dig into next, leave it in the comments below. We read every single one, and some of the best episodes start exactly there. This documentary explores current scientific research related to human spaceflight, space medicine, and the biological challenges of long-duration missions and potential Mars settlement. It is intended for educational purposes and distinguishes established findings, largely based on research aboard the International Space Station, from future possibilities that remain scientifically uncertain. No human has ever lived permanently on Mars, and many of the long-term biological and psychological effects discussed in this documentary remain the subject of ongoing research rather than settled fact.